Hi, I'm Vincent White, and I'd like to introduce you to a new concept in AML screening. First, I'll start with a bit of background to give some historical context. Always better to start than end with an iceberg. Conceptually, a popular way of representing hidden cost. I don't want to make a point about the size of enforcement penalties or question the effectiveness of the enforcement regime, but rather set the stage by emphasizing the breakdown of costs. KYC constitutes a significant portion of AML budgets, up to 40% in some cases, and the composition of that spend is largely manpower rather than technology. It's still a very labor-intensive process. Much effort is spent collecting and collating information, screening names against lists, and going through results. Many of those processes are manual, and compliance teams need ever larger headcounts to process and resolve alerts. Then there are the indirect and less visible costs. The increasing time spent to onboard new clients, several weeks in some cases, leads to a poor customer experience, friction, frustration, and many applications are invariably abandoned. Poor data management and quality and error rates and controls, all of these together have a negative impact on the client lifetime value as well as significant revenue loss. Many organizations have found themselves lumbered with very large operations associated with the end-to-end of screening, and it's a glaring problem. The risk data market is at a turning point. Since 2000, firms have been reliant on using matching algorithms in tandem with risk assessment techniques, screening alphanumeric customer identity data against databases with millions of names of sanctioned individuals, PEPs, and persons of interest, and further against unstructured data in the form of adverse media. Risk data providers offer very comprehensive databases of high-risk individuals, and the name-based screening software has evolved over 20 years to incorporate more sophisticated handling of the multilingual complications of matching. But their growth has been one of the contributing factors to ever more matches and false positives being produced. The more significant causes are the inherent characteristics of names, and that we choose to configure screening software with various types of fuzzy matching techniques to avoid missing true matches. So firms are saddled with this labor-intensive burden of processing huge volumes of alerts that result from an alphanumeric screening process. Now, to the present day, the Facepoint concept is simple and straightforward, but genuinely game-changing. We have developed a new no-name AML KYC screening concept. This is the evolution from clunky alphanumeric matching, extending the application of biometrics from identity verification to watchlist screening. It's effective because biometric attributes are significantly superior to names in terms of uniqueness and authenticity. But the headline-grabbing appeal is the speed and massive reduction in results, specifically false positives. Biometric screening is more precise, generates less noise, fewer false positives, helps accelerate KYC onboarding processes, and identify risk earlier, and this results in saving manpower, time, and money. We are a disruptive technology and research company created at the end of 2017, which last year joined forces with Idemia. In this collaboration, Facepoint is the provider of the risk intelligence data and Idemia the biometric technology under the bonnet. Now we've reached a watershed moment and a paradigm shift in screening is coming. The central problem is one of identity resolution, and in the simplest sense, biometric screening offers the possibility of using a defining, almost unique identity characteristic. We like to say there is so much more identity information in a face than in a name. Two key questions underpin this new approach. Why are we using identity labels with less uniqueness that present so many problems in matching and which are vulnerable to falsification? And why are identity verification and screening separate processes? If we look at the risk market today and the ecosystem, at Facepoint we cover the same territory as the existing alphanumeric data providers: sanctions, political violence, terrorism, organized crime and mafia, financial crime and corruption, and PEPs. Where we diverge is the addition of our multimedia content and photo library. This represents uncharted new territory in terms of covering data that is not on any kind of list, nor in any unstructured adverse media content. The Facepoint image database presents a compelling proposition in the way it overcomes the vast majority of the issues associated with traditional name screening methods, and also identifies previously unknown persons of interest or heightened risk. Although not in itself, our data is expanding rapidly at 10% month on month. And unlike with alphanumeric data, as we grow, there isn't the attendant effect on results volumes because of the relative uniqueness of faces. So the reduction in results volumes is the big game changer, but biometric screening also offers the speed and frictionless qualities that are increasingly demanded by consumers and businesses alike, as technology enables accelerated journeys across the board in payments, travel, and any process requiring identification. KYC can also benefit from this, and the particular bottlenecks in onboarding and due diligence processes are ones that stand to reap these rewards. As we have amassed considerable content extracted from videos deliberately broadcast by terrorist and criminal organizations as part of their propaganda activity, this also affords a novel opportunity to address narrative or implicit sanctions. Where there is an edict that sanctions an organization, but it is open-ended and does not explicitly designate a list of named individuals, this is very difficult for name-based screening systems to deal with. With a biometric system, we no longer need to know an individual's name or other identifiers. It is sufficient to know that they have participated in, say, a terrorist act to associate them with that group. And should they one day appear thousands of miles away trying to open a retail bank account, they can be screened and identified. Now, stepping back and looking at the current state of affairs, I've worked for the best part of 15 years trying to understand how to get the best results in alphanumeric screening in the context of KYC. Data matching, string comparison have many applications in other areas, and the technology is mature. Computational linguistics, however, is a newer discipline, at least in its application in screening. This attempts to address the nuances of multiple languages and specifically names in screening software. Probably the most important feature of names at the root of the problem is homogeneity. This is an issue in all languages. Each one has common and rare names, but in some cases it's more pronounced than others, particularly in some Asian languages. In China, 85% of the population share the most common 100 surnames. This makes identities less unique, and hence we rely on matching secondary fields such as date of birth to disambiguate identity. However, these are not always available. The second major headache is multilingual names, translating and transliterating. We try to standardize names to a common denominator, typically English. Gaddafi was a textbook example that led to a vast number of possible permutations as a result of multiple conventions and applications per the geographical origin in the Arabic-speaking world. We can use phonetic or other fuzzy matching techniques to address this, but invariably we pay a price in terms of more false positives. So to summarize, in alphanumeric screening, homogeneity in names and the many language-related problems leads to a very unfortunate result, a trade-off between precision and recall. That is the goal of identifying all the true positives, not missing any matches, and not getting too many false positives. All the clever variations of fuzzy matching, hardwired programming of linguistic anomalies, and more recently applications of machine learning help reduce the risk of false negatives, but at some cost in terms of false positives. But as we can't change the essential characteristics of names, what can be done to calibrate algorithms and make screening software more intelligent has a limit. I've covered the unknown persons and narrative sanctions, common names, the absence of secondary identifiers, and matching complications from transliteration or syntax variation. What remains is deception, firstly altering one's appearance. The fact is that cosmetic surgery will not fool modern biometric technology. You simply cannot change the fundamental dimensions of the face. And finally, and perhaps most importantly, is document fraud. Watch list screening is predicated on identity verification, and that has always been the Achilles heel. If someone obtains a false identity, they can slip through the watch list screening process, and that's what criminals and bad actors have been doing with impunity for the last 20 years. The content of the Facepoint database is truly original and exclusive. There were the occasional organizational charts of drug cartels published by OFAC, but no one has endeavored to create a comprehensive image library of all sanctioned individuals, and that was our top priority. Then we added to that images of all denominations of political violence, extremism, and terrorism, enriching each profile with metadata comprising the conventional identifiers, names, date of birth, country, position, and so on. These are still, of course, useful, and we are not replacing them wholly with biometrics, merely taking the face as the primary attribute. In cases where the conventional identifiers are not known, it doesn't matter. And for most of the video content, these are analyzed and still shots extracted without needing to know the identity of an individual. An extremely rigorous and robust research process is a necessity. We need to understand the provenance and reliability of sources, verify and attribute thoroughly. We are intensely focused on compliance with applicable data protection regulations, but it's a complex area that does not permit a detailed exposition here. But in brief, we are operating according to the exemptions stipulated in Articles 6 and 9 of the GDPR, where the processing of personal data, including biometric data, is permissible without consent if there is substantial public interest, and that includes the combating of financial crime and terrorism. Facepoint offers different types of platform and delivery channels for its no-name screening solutions, each addressing a different need. It's a straightforward subscription business model with API priced in per-check brackets. There's an online web interface which requires no installation or setup, exactly the same as a world check or similar. Image files are uploaded in a drag and drop fashion. There's a near zero footprint in terms of logging. The input and output images are not stored, only for the fraction of a second for the matching to take place. The scoring is probabilistic, as with other types of biometric matching. These are not only far more accurate, they also give a real indication of a match being true, in contrast to alphanumeric scoring systems, which are also a measure of closeness of match, but that's not the same as the probability of a match being true. This again is because most conventional matching algorithms do not account for how common a name is. There's a web interface available with a RESTful type API, which can be integrated in many types of environment, platform, or applications, caters to a higher volume batch checking. And one other alternative use case is to compare a data set of images amongst itself, a deduplication exercise, but one that can uncover identity fraud, which is, as I mentioned before, is the Achilles heel of KYC. Just very briefly, I wanted to show the results from a couple of proof of concepts we've carried out, which are truly staggering, but in this era of record high levels of account takeover, perhaps not so surprising. By any measure, 0.4% is a very high proportion of documentary fraud. These are individuals we can identify as having the same face but with different identities. Despite the high number of comparisons needed, the process can be carried out very rapidly and again with a high level of precision and recall, in part because the quality of images from identity documents needs to meet certain standards in terms of quality and consistency. Thank you very much. Please contact us if you would like to find out more. Facepoint is a French technology company which combines the database of high-risk individuals with a state-of-the-art biometric engine. Facepoint has taken advantage of enhancements in biometrics and artificial intelligence to launch a new AML KYC screening solution based on facial recognition that no longer relies on inefficient name-based data matching. It reduces false positive rates by orders of magnitude. It overcomes identity fraud and deception. It gives more comprehensive coverage of open-ended narrative sanction, and it provides an accelerated, frictionless customer onboarding process. This is the Facepoint online interface. For higher volume batch checks, we would use the API, which is capable of up to 1,000 checks per second. But there are several use cases for the online platform, including taking the higher risk or difficult cases that result from the text-based matching process. Firstly, the familiar face of Kim Jong-un. This is the actual passport he used while at public school in Switzerland about 25 years ago. This case illustrates a number of points. Firstly, that with a false identity, a certain Jose Prague, legitimately issued by the Brazilian embassy in Prague, this would avoid any watchlist alerts as a PEP or sanctioned individual. It's also a poor quality, grainy black and white photocopy. So despite the suboptimal source image, the considerable age gap, and that he's changed physically over the years, we still get a high scoring true positive match. And by setting the score threshold high, we can remove the noise of false positives and just focus on whether there is a true match or not. This is radically different to the experience of text-based screening, where the true positive match could be buried in a mountain of false positives. The reverse of each image shows that the traditional secondary identifiers were available, and of course a source link for attribution, audit, and to show provenance of the source. In this next example, a Malaysian-born con artist who stole multiple identities in the United States and perpetrated fraud on a grand scale. It is a common misconception that facial recognition suffers from age and ethnicity bias. Historically, this was the case with poorly trained algorithms, but the advances in AI in the last few years have massively improved matching, and the precision and recall is now orders of magnitude better. Demographic differentials do exist, but they are minimal when the source image is of reasonable quality, as we expect to see with copies of ID documents, rather than CCTV images or other sources. Now on to show you a real-world case. This is the LinkedIn page of a French gentleman who works as a freelancer in the construction sector. When we screened him against the Facepoint data, we found that he had a double life as an ISIS operative. On the reverse of the card, we can see that this particular image is extracted from video taken from propaganda broadcast by Islamic State. And finally, this is Andrew Moran. After years of evading arrest in which he traveled across Europe, this was one of the UK's most wanted persons, a prolific criminal who had plastic surgery to alter his appearance. But this drastic measure of physical deception still cannot fool biometric identification. And this concludes the demo.